Hi guys, Techalyzer here. Have a bunch of Christmas lights here. If I plug them in, let me see, because I have something that I need to be careful about. Okay, that's where it is. And as you can tell, maybe if I can hold these up. Is that right? Oh, sorry, my wife is home. Yeah, so as you can see, half of these aren't working. These two here don't light up. 2 out of 4. And that's a shame because it's a system like 200 light bulbs, I think, and half of them are dead. Now, one obvious reason would be where is the reason? I have lost my reason. Really? It's so weird when there's multiple items. You're sure of where they are, but then you, oh, there it is. This is one clear reason why it might not be working. But as far as I remember, this thing wasn't working even before this happened. So, and what I've seen with these Christmas lights is that sometimes I think it gets shortened out or something, and the whole output fails from within the circuit board. So I'm gonna open this, make sure the wire is still there connected, because I have tried to. What the hell, the screwdriver doesn't work. I have tried briefly shorting out the contacts on that broken bulb, and that should make the others light up as it's connected in series, but nothing happened. So I'm thinking there might be something a little bit more serious here. Now take a look at how these things are built. Look at this wire here. That one on the right. And this is the 230 volt AC input. So yeah, that's how these things work. Maybe they thought about, if I pull just a little bit, this will come off. There you go. not even too much force. Well, that wasn't the problem. That's the 230 input. I'm thinking about these, and there's definitely something flapping around in the breeze here, but they're still connected. They obviously require some more solder, which I'll put in a minute. And where? I'm lost here. I don't know where I put my solder. That's bad. Ugh. Okay, so I didn't record this. I took care of that wire here. Also used some hot glue to keep these wires in place. Remade all the joints, minus these tiny ones on the actual chipboard. I'm gonna have to. You see these ones on this line here. If you try this, please be sure that this is disconnected from the mains. Now that was a weird one. It's kind of at a distance from the pad on the board. These boards are crap anyway. So yeah, now just remade these tiny squarish joints. Now I'm gonna try plugging it in again. Okay. Nope, they're still dead, which is quite obvious because I have that burnt one. Let's see if this does anything. I'm gonna try. Oh, that's not good. You know what? I'm gonna use the lid to keep the board in place. I want to make them all kind of stay permanently on, and then try to short out this thing. Nope. And also please note that by shorting out the filament wires from a broken bulb like this, even if it works, it's just a quick test, because if you're gonna just twist them, you're gonna increase the voltage on every other light bulb and they eventually will all burn out. So it's just something to make a little test. Now I'm gonna pull this out. So there's only two. Okay, that must be a common. This trace on the left side seems to be the common because it's connected with the mains directly. So that makes me think, oh, these can get quite hot. I hope it's okay if I keep them, yeah, it doesn't seem to be that bad. So I think I must measure between the left one and each of those on the right side. Let's see, this is permanently turned on. It would be nice to have the camera overhead now, but maybe like that, a little bit of a boost like this. Okay, so that is point something volts. I'm holding it in my hands now. It's on AC. One of the prods broke off. So let's see what we get here. Yeah, this is really nasty. Exposed wires and live AC. What could possibly go wrong, right? This is 124 volts, which sounds quite right for like half of the job. And this, another 126.6, so I am getting voltage on this, which is really great because I thought that the circuitry is broken. And in many cases, being the fact that this is an integrated blob chip, most of the times it's just blown away and nothing you can do. So I'm gonna unplug. I'm not sure if I'm gonna keep filming this. Now basically it's gonna be hell because I need to test each and every single one of these, which don't light up, and as you can see, they're pretty well insulated. I'm thinking about, there's no way to do this, I just need to cut. And the wires are so bad. Actually, I'm curious now. If I measure the resistance of the loops, I should get a 0 on the ones that don't work, just as it is now. Obviously, because that's is that our resistance? Yep. What do I get? That is 135 ohms. This is definitely the good one. This is completely open. You know what? I'm gonna try to. Actually, I'm gonna solder these two together, so I can close the loop. Don't know if that works. This seems to be copper, and copper is very solderable. That was pretty tough, but I think it gets the job done. I think I can actually see better than with my own eyes here. If I can make this damn thing focus. That's weird. Seems like it, you know. Let's see the resistance now. Not like this, you fool. I need you on the side. Check if it's disconnected again. This is the good one. Do I get anything? No, obviously these two. It's still open, so there's a blown bulb somewhere. And this is pointless to get on camera because it's gonna be just me checking couple of hundred light bulbs, and it's not something particularly interesting. You basically just take a look at it in front of a light and check that filament as a visual inspection. But also somehow I'm gonna have to measure the resistance, and I don't know how I'm getting inside the wires to measure, besides just cutting every single one of them and reattaching them back, which I'm crazy, but I still want to find some other method, but that sounds stupid. But I'll do it if I have to. I don't know. I'll have to figure out a way to do this. I guess this is it for today. Thanks for watching, and see you next time. Bye bye.